Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Buell Januzzi, Director of the university's Seward Observatory and a member of the Board of Directors of the Giant Magellan Telescope, or GMT. Welcome, Buell.
Great to be here, Tim.
Buell, I know the Mirror Lab here is now working on the final mirror for GMT, so I'd like to talk a little bit about the telescope. With telescopes like Hubble and James Webb in orbit, what is the role for a telescope on the ground like GMT?
That's a great question. People often ask, why do you need more than one telescope? And astronomy and astrophysics is done by a combination of a telescope, an instrument, and people. And the combination of a telescope and an instrument does different things. And giant telescopes like the Giant Magellan Telescope enable you to do some things that are unique. One of those is to gather more information, more light per unit time than a smaller telescope. And the other, and this is really important, is the ability to see fine detail, to see features that you wouldn't see with a smaller telescope.
GMT is located in Chile rather than someplace like Kitt Peak. Why is that?
In order to see the whole universe, the whole night sky, you need to have telescopes in both the northern hemisphere and the southern hemisphere. We're actually building all the components of the Giant Magellan Telescope in the United States and then reassembling it in Chile so that we can see the southern sky, the same sky that ALMA and other unique observatories are able to observe from Chile.
How does the image quality of GMT going to compare to something like Hubble?
So if you go out on an early evening and look up with your eyes, you're going to see the planets as little dots because your ability to see fine detail is limited by the size of your pupil. But if you had a large telescope, you see finer detail, and it's directly proportional to how big your main mirror, your primary mirror, is for the telescope. The GMT is 25 meters in its primary mirror. The Hubble Space Telescope is 2.4. It's that ratio, 10 times bigger, means that GMT will see 10 times the detail that the Hubble Space Telescope sees, 4 times the detail that the James Webb Space Telescope sees. So when you're trying to image a planet orbiting a distant star, that's what you need, the ability to resolve the spatial distance between the planet and the host star.
GMT is a partnership, and the University of Arizona is one of the partners. What are some of the other things that the University of Arizona is going to be contributing?
So most importantly, for the lifetime of the observatory, we're going to have our faculty and students and staff as users of the facility. But we've been involved in not only the overall design, which was inspired in large part by the work of Roger Angel and others in designing the LBT and other telescopes that we've been involved in. But we're also actively involved in all of the wonderful science, planning, and execution that GMT will have. This is studying exoplanets to the first stars forming in the universe, to finding the optical counterparts to neutron stars that merge. It's a very diverse set of science cases. I am quite sure our colleagues in our sister department, LPL and Planetary Sciences, will use GMT to learn new things about our solar system as well.
How soon will GMT be coming online?
Always a sensitive question. Not as fast as we would like. Building these giant observatories is in many ways modern cathedral building. We are building for the next generation. So we started developing the technology that's going into the GMT almost 40 years ago with the creation of the Mirror Lab, which is making the primary mirrors. We won't finish until the early 2030s when the first instruments are being commissioned. So frankly, I hope to be retired by then, but our current undergraduates will hopefully, some number of them will have gotten involved in astronomy and be lining up to use the GMT.
It's a fascinating project. Thanks for coming in, Buell.
Thanks, Tim.
Our guest today has been Buell Januzzi, an astronomer who is working on the upcoming Giant Magellan Telescope. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.